Okay, now suppose we have this model yi equals to beta 1 plus beta 2 x 2y plus so on to beta k x ki plus mu I. So this is the general model which we do. In case of simple linear regression, we have just yi is equal to beta 1 plus beta 2 x 2y plus ui. This is what we have in case of simple linear regression, in which only there is only one independent variable. In case of simple linear regression, supposedly in case if you have this data with you, what you intend to do is that you try to fit this line, and this line is basically this: yi hat is equal to beta 1 hat plus beta 2 hat x 2y. Okay, so for each level of x2, okay, which is given by this I, you will have an estimated y. These hats are actually telling you these are the estimated y's. Fine. So what basically you want to do is that you want to learn about the world. You want to test theories. Okay. So, well, you want to learn about, say for example, there is the law of demand. Okay. You have the empirical data with you. You want to learn about the world. Okay. When you see a data, you try to plot it, you'll get some relation out of these among the variables, and you learn something about them. What is the relation? Which is causing what? Okay. And you try to test the theories around. Okay. So for example, in case of law of demand, well, you know something theoretically, you try to test it empirically, well, that's true or not. And then you also try to forecast. You use econometrics in forecasting also. That is, you try to forecast that what is going to be the level of variable in the next period. That period could be a day, could be an hour, could be anything in time. Okay. In both the cases, you're interested in finding out this best fitting line. This is the entire goal of this course. You try to find out this best fitted line. Okay. And while doing so, you have to take care of two things. One is specification and another is estimation. So while specifying your model, you try to locate that what are the main variables which you should include. Okay. What are the main variables which you should include? Supposedly, in case if you have your yi equals to beta 1 plus beta 2 x 2y and so on, you try to find out, say for example, in case if you have that income is dependent upon education level. So you try to think that what are the most important variables which are affecting income. Okay. Education is one of them. Are there any other variables? Or in case if there are, then what are their statistical significance? How significant these variables are? You try to think that what functional form this relation should have. Okay. Should you take a linear relationship? Or in case if you're talking about growth, then should you take a log-lin relationship, or you should take the semi-log relationship, or you should take a reciprocal relationship? What is the functional form which you should take up? You try to think about whether you should include some dummy variables also. Okay, dummy variables are those variables which are binary. Okay, not necessarily always binary. Okay, they can have they take up the values 0, 1, or it could be 1, 2, 3, 4 also something. Okay, so say for example, if season is hot, you'll give the value 1 to temperature. In case the season is cold, then you give the value 0. Okay, something like that. I'm not talking in general to this example. I'm talking in general. Okay, I'm not talking specifically to this example. In general, I mean, these things are true. Then should you take the distributed lag model? That is, should you take the dependent variable also as one of the factor? Okay, the lag of the dependent variable as one of the independent variable. Okay. These are the things which you have to take care of in specification. Estimation, then you have to estimate it. Once you have specified your model correctly, once you have all the variables put in place, once you have proper functional form, once you have checked for that should it have a distributed lag, or you have also checked for should it include dummy variables, should it include some other variable, okay, which is affecting it, then you come to estimation. How do you estimate this model? Okay, then you can estimate it using various techniques. One of the technique which we will generally use is OLS, your ordinary least squares method. And what if your model is not specified correctly? Okay, then your estimation results will not be proper. They will not be of the form which you want. There could be the problem of multicollinearity. That is, the independent variables themselves are related with each other. Okay. In case if there are, say for example, in case if you have the model y, I is equal to beta 1 plus beta 2 x2i plus beta 3 x3i plus ui. Independent variable mean that they should be independently affecting y. Okay, there should not be any relation among themselves. Okay, in case of x2 and x3 themselves are correlated, you cannot separate out what is actually affecting y. Okay, we'll be talking about this in detail later on when we'll pick up multicollinearity. Is there a problem of serial correlation? That is, in case if the errors are correlated. Okay, when you run a regression, then you estimate y. You estimate the dependent variable based on the parameter estimates which you get from regression. Now, these estimated dependent variable could be different from the actual values. Okay, and this gives rise to errors. Okay, and in case of the errors in one period is related to the errors in second period, it gives rise to the problem of serial correlation. Is there a problem of heteroscedasticity? That is, are the errors, is the error variance not constant? Okay, for each of the observation, is the error variance different? In case if it is, then it creates certain other kind of problems. Your idea is to get the estimates which are blue, which are best linear unbiased estimates, unbiased efficient estimates. This is the one you can't do better. Blue estimates. This is what you have to get. Okay. And in the entire course, we try to revolve around it. How do you get these blue estimates? How do you get the best estimate? How do you get the linear estimate? How do you get the unbiased estimate? How do you get the efficient estimate? So, because all of these problems, your multicollinearity, your serial correlation, heteroscedasticity, all of them, they violate some of the assumptions, and hence the estimates will not be blue. Then you'll have to correct these problems, and then you'll have to finally present your results. Because without correcting these problems, in case if you believe whatever results you're getting, you might be in a trouble. So you have to identify the problems. In the data, you have to identify the problem. Is there a problem of multicollinearity? Is there a problem of serial correlation? Is there a problem of heteroscedasticity? Is there any other problem also? Is there a problem of omitted variable bias? Or you have included unnecessary variables? Or what? What actually you have done wrong? Once you have identified problems, you have to correct them. There are various ways of correcting it. There are tests all around the place in order to correct all of these problems. And once you have corrected all of these problems, then the kind of the estimates which you get, you can rely on them. Then you can be sure of yourself that yes, this is what I wanted and these are the results in place. Okay. So, okay.